I told you the reason why we discuss the joint probability and the marginal probability for before, because of this one, conditional probability. Let me give an example for the conditional probability. Okay? I want to play basketball tonight. Let me see. Do you like play basketball?
No.
No? How about you? Do you like it? Okay, could you stand up for me? Okay, please look at him. Sit down. Tonight at the gym, we are going to play basketball, 1-to-1. How do you think? Who's gonna win? Why? Yes, I'm short. He's a taller. That is a good point. I can remember your name. How do you think? Who's gonna win? Him? Why? Any other reason? Yes, I'm short. Any other reason? Yes, that is me. I'm short. He's a taller. I'm shorter. Him? Yes, why not? Any reason?
You're short.
Any other reason, please? I knew it. He's gonna win. Yes, but I need another reason.
Because he's good at it. He likes it.
I love basketball. Why did you think I hate basketball? How do you think? Who's gonna win?
I don't know.
Come on.
I mean,
Be
you may
honest.
Be terrible, and you may be good. Just because you're short doesn't mean you're not good at
I
basketball.
hate basketball.
Okay.
Please look at me. I'm short. Yeah, she said I'm too short, right? So he?
Him,
Yes.
I guess.
Any reason?
No.
He, right? Yeah. You look at him.
Maybe because he's younger.
What?
I'm not.
I'm
saying
too old. 48 years old. Must be slow.
No.
Why not? Why not? Yeah. I think you're gonna win. Taller than me, younger than me, looks stronger than me. Okay. Tonight I will play my friend, not you. Yeah, you are too tall, too strong, too younger than me, right? Let me play with my friend. How do you think? Who's gonna win? My friend. Why not?
I don't know your friend.
Oh yes, yeah. He might be shorter than me. He's maybe 90. See, it is the conditional probability. You saw him, and he stand up, right? And you saw how tall he is, right? He is taller than me, and I don't know how old are you, but you looks younger than me, right? And good, the shape of the body is stronger than me. We knew some information, even though we have a small information. Why not? We have to use it. What we have to do in statistics? Do our best. Yes, why not? But when I suggest to you play with my friend, you don't know who is my friend. No information. We just do it. We just do our best without any information. But any small information, we have to use it. That will be the conditional probability. The winning chance for the basketball, yes, it quite depends on the height, power, faster. Why not? So we are going to discuss the conditional probability. That is the conditional. It's good? Conditional probability. We are going to use this kind of notation. P, bar, A. The bar, that is the indicator. That is a notation for the conditional probability. We can read it. Conditional probability of an event of B given event A. The event A is given. That means it's last time. It depends on height. Depends on age. Yeah. You know. So the event of A is given. So we are going to take the conditional probability based on the event of A for B. Okay? So let me see. What is the experiment? Rolling one die. How many possible outcomes in the sample space? Yeah, here is a big S, sample space. How many possible outcomes when we are rolling one die? 6. Who are the 6? 1, 2, 3, 4, 5, and 6, right? So the sample space will be 1, 2, 3, 4, 5, and 6. And now here is the 2 events. F, 5, we will get 5. What is the probability of the event of F? Get 5? 1 out of 6, yes. Here's a 5, 1 out of 6. How about the next one? O. O is another event. We will get odd numbers. How many odd numbers? 3. 1, 3, and 5 out of 6 again. So the probability of F is only 1 out of 6. The probability of O is a 3 out of 6. It's half. It's a 50%. Okay, so based on the two events, F and O, the very first one, yeah, it is not conditional probability. F, yeah, I told you, it is just 1 out of 6. Now the second one, it is the conditional probability. F given O. O, odd number. That is a given. Here's a die. Right? I'm rolling the die and get the number. I got 3 now. 3, odd number. And one more time. Now I have a 4, even number. Rolling a die just once. So the sample space was a collection of 6 numbers. 1, 2, 3, 4, 5, and 6. Okay, now in part B, O, the event of O, it is given. What does it mean? I'm rolling a die. I didn't let you know what I got, right? But I said I got odd number. It is given. We knew it. I had an odd number, right? And the conditional probability will be, what is the chance? It will be F. It will be 5. What is the chance?
1 in 3.
Say again?
1 in 3.
1 out of 3. Why? I told you, I got odd number. And the chance it will be 5, 1 5 out of 3 possible odd numbers. Does it make sense? It is the conditional probability. O, odd number, given. We knew it. So it will be 1 5, 1 1, 1 out of 3. Let me try the next one. Not F. Not F is given. We need the conditional probability O, odd number, given when I will say it is not 5. Can you understand? Okay, so I'm rolling a die and I say it is not 5. It is not 5. And we need a conditional probability. Then what is the chance? It is odd number.
2 out of 3.
Say again?
2 out of 3.
2 out of 3. Okay, good try. Okay, how did you get 2? Who are the 2? Numerator.
The 1 and 3.
1 and 3. Why not 5?
Because it's not.
Because I said it is not 5, right? So now, how many odd numbers? Only 2, yes. 1 and 3. 2, good. So, numerator is a 2. So now we have to count is how many denominators? How many? How many did you say?
Said 3.
Did you say 3? Why?
Because that's the odd numbers.
No. Now, odd number is not given. What was given? F. I mean, not F. Not F was given. What does it mean? It's not 5.
Would that be 2 is the denominator?
No. 2 was in the numerator, and now I'm asking you, who will be the denominator? How many in the denominator? Not F. Not 5. How many numbers? Not 5.
5.
5, yes. Who are the 5s? 1, 2, 3, 4, and 6. Okay? Because I said it is not 5, then what is the possible outcomes? Now, I can say now we change the sample space based on the given event. Before, in part B, I said it is odd number. So the new sample space, the new possible outcomes, only 3. 1, 3, and 5, because I said the odd numbers. And based on the new sample space, odd numbers, the given part, we are going to take another probability. It will be the conditional. In part C, I said it is not 5. So the new sample space will be 5. 1, 2, 3, 4. Not 5, but 6. Then we can take conditional probability based on a new sample size, except 5. Good, right? So we have to have a new sample space. Here is a rule. Here is a conditional probability rule. The A, B, B, A, it doesn't matter. But the textbook gave us the rule, a conditional probability of B given A. Then it would be probability of A and B over probability of A. The probability of A, the event of A was in the given part. It is a rule. It is the rule. Let me try. Let me try to get this one. F given O. By the rule, the conditional probability F given O will be probability F and O numerator divided by, who was given? O was given. we can take two probabilities separately. Let me try to get F and O. You know, when we made a Venn diagram, and was in the middle, right? Yeah, please remind where was the end. F and O. F, 5. And O, odd number. How many numbers? 5 and odd number. How many? You know, always we have to think is based on the sample space, which was 1, 2, 3, 4, 5, and 6, right? Because you know the probability F and O, it is not a conditional probability. So based on the sample space with the 6 values, yeah, we can take the probability separately, numerator and the denominator, to get the conditional probability. So probability F, 5, and O, odd number. How many numbers? 5 and the odd number. It's only one. 5. 5 was odd number itself, right? Who is Deho, Dr. and the male? Who is he? I am. It's only me, right? It's a 5 and odd, it's just 5. Just one value, 5. Out of how many numbers in the sample space now? 6. I just take the probability F and O. Now we take the denominator. Just O. Who was the O? Odd number. How many odd numbers? 3. 1, 3, and 5. Out of 6 again. Because we have to take them based on the same sample space. 1, 2, 3, 4, 5, and 6. You know, when we apply the conditional probability rule, always we cancel out the denominators. We cancel out the denominators. The remaining ratio, 1 out of 3. How much was it? We had 1 out of 3. Okay? By the rule, or just to think about who was given, and then now how many outcomes in the event based on a new sample space. Either way, we are going to have the same conditional probability, 1 out of 3. One more time. I will make smaller. In part C, O given, not F. So simply apply the conditional probability rule. It will be probability O and not F over probability of the given part. Who was given? Not F. Okay. Think about this one. O, odd number, and not F, not 5. How many odd numbers? Not 5. 2. 1 and 3. Not 5. 1 and 3. 2. Out of 6. So that is a probability O and not F. Even number and not 5. Only 2 out of 6. How about the not F? How many numbers not F in the sample space? How many? 5. 1, 2, 3, 4, and 6. 5 out of 6. I told you, always the denominators is cancel out. By the rule, we have a 2 out of 5. How much was it? Yes, it was 2 out of 5. So either way, we can have the same answers. Any question? Look at this. Probability of A and B. Who was this? We discussed before, yesterday. A and B. Yesterday, we discussed the joint probability and the marginal probability. Do you remember that? The probability of A, yes.
This may be a dumb question. So on the homework yesterday, I kind of knew which one to do, like the adding and then the subtract, because that's what we learned. But on our test, are you going to have, like, tell us to do which rule and we do it, or do we just have to know which rule to do?
No, I do not suggest to you by this rule or that rule. But look at this one. When I gave you the homework yesterday, that is all based on the addition rules, because we had only addition rule. The addition rule, special one or general one, all for probability of A or B. You know, yesterday I told you we have only two things, or and. Now it is and, right? Now it is probability of A and B. You know, the and, that is a key. We do not apply the addition rule. We have to apply another one. We are going to take the rule today. But when you know, the reason why I do not let you know which rule do you have to use, right? It's at least you have to understand. If it is or, if it is and. If you interpret it is or, apply the addition rule. But when you understand it is A and B, then we are going to use another rule. Yeah, we are going to discuss the rule today. Okay? So remember, yeah, it's very confused, right? Because, because we had two things, and or. But another way, it's very simple. You have to choose either one. It's only two choices, and or. And sometimes it's confused, but it's better than three, right? So we are going to discuss one by one, and then I will summarize them. Yeah, case by case. Good, right? So now we have an and, A and B, which was the joint probability yesterday. Do you remember the table? Rank, associate, and 40s, and 50s, and joint probability. How about the denominator? Just A, just also associate, just over 60s. It was the marginal probability. So can you understand why yesterday we discussed the joint probability and the marginal probability? It's based on the cross table. Yeah? in the rule, in the conditional probability rule, we need the joint probability and the marginal probabilities separately. And then take the ratio. That will be the conditional probability. Good, right? And one more. It's messed up. Look at this. Okay, let me choose the red color. You know, when we got this one for the first time, 1 out of 3. Can you remember how did we get 3? Why here was a 3? You know, actually, just a second. It was the conditional probability F given O. The value 3 here, it was from O. The given part. Do you remember that? Why 3 again? Odd number. The event of O. 1, 3, and 5. Here, you know, by the rule, by the conditional probability rule, finally, we had 3 there. But actually, it was 3 out of 6 in the denominator. But cancel out the denominator of the denominator, 6. But it's actually, there was a 3 here. Where it was from? By the rule, in the denominator, at the bottom, there is the given event. It's the same idea, isn't it? See, the first 3, it was here, the given part. Even by the rule, 3 out of 6, it was from the given part. You know, exactly what we did and what we are doing by the rule is the same idea. Yes?
Why is the probability of the given not 1 since we know it happens?
That is a good question. You know, okay, let me try answer. That is a good question. Think again what we are doing. You know, the question is, we knew the given part. But why it is not the probability of 1? Because we knew it, then 100% we knew it, right? Yeah, that is your question, right? You know, okay, let me use this one, the formula. It's actually, we need the probability B given A. Honestly, we don't care. What is the A? Do you know what? I mean, we care. Yeah. We want to know what is the A. But, you know, we want to know what is the probability of B. It's not A. You know, the right-hand side, how can we get the conditional probability? It is the technically we take the joint probability and the marginal probability and just take the ratio technically to get the conditional probability. But the main focus was we need the probability of the B, not A. Then what is the A? We knew it. We knew the event of the A. It's based on the information I told you. Based on what we knew, is actually we need the probability for B, not A. So now I can say we don't need the probability of A. Yeah, you are right. Yeah, 100% we knew who is the A. What is the probability of A? But but that is not the focus. Yeah, we need the probability of B, but we knew who was the A. But technically, we have to take the probability of A here. But the reason why now it is not 100%, why it is not 1, because we have to take the probability of A in the denominator based on the old sample space. Absolutely based on the new sample space for the conditional probability, the probability of A,
Is 1.
I have to say now, based on the new sample space, the probability should be A given A. You understand what I'm saying, right? So, you know, the rule has 2 parts, the left one and the right one. For the right one, we have to take them, the joint probability and the marginal probability, based on the old sample space. But in another way, the left-hand side, the conditional probability, we need the conditional probability based on the new sample space. So the left one, right one is based on the totally different sample space. But technically, yeah, we can take the conditional probability from the right-hand side to get the left-hand side. Right-hand side, left, yes. It's good? Okay, yeah, that is a good question, thank you. Okay, so here is another example. It's not another one. Yeah, do you remember this table? Okay, so let me take now conditional probability. I'm sorry. Part A, first, we need the unconditional probability. A selected faculty member is 50. Actually, it is the marginal. It is the marginal 50s, the marginal probability. To remember, how much would be the marginal probability? 253 out of 1164. Marginal probability. Now, part B. Now it is the conditional probability. For what? Oh, here is the given. Can you see that? Given. So now I can state we need the conditional probability 50s given assistant. Let me apply the rule first. Then it will be, we need a joint probability first. Probability, 50s, and assistant. Over what? Who was at the bottom, in the denominator? 50s or given event assistant? Given event assistant at the bottom. By the conditional probability rule. So now we have to take the 2 probabilities separately. Okay, let me see the 50s and joint assistant. 50s and assistant. How many? The joint, there is the 36 out of, based on old sample space, 1164. We are going to cancel out, but the joint probability will be 36 out of 1164. Denominator. Marginal probability. Assistant. Just assistant. How many? 320. Out of, based on the old one again, 1164. Always cancel out. So the conditional probability, 50s given assistant, by the rule, it will be 36 over 320. Any question? Let me take the conditional probability directly. Assistant was given. So we knew when I select one faculty, I knew it is, he or she is assistant professor. I knew it. Then I will ask you, what is the chance he or she is a 50s? Can you understand, can you interpret what is the meaning of the conditional probability 50s given assistant? It's like as when we rolled a die and I told you I got odd number, I got not 5, it's like that. I just tell you I chose assistant professor. And then I will ask you, what is the chance he or she is 50s? Then now you have to take the probability. It's only based on assistant professors. So the denominator, it should be the number of assistant professors. 320. What was the question? Then now, what is the chance he or she is a 50s? 36. 36 50s out of 320 assistant professors. Exactly, it is the conditional probability of 50s when we knew I select assistant professors. Either way, it will be same. It should be same. It should be same. So it is the conditional probability. We knew who was selected. So based on the information, we have to take another new probability. Depends on what we knew. It is the conditional probability.